Hello and welcome to the second edition in our series of industry insights of using vision as a sensor in industrial settings, brought to you by ADLINK and Intel. Hi, I'm Paul Wealls and your host today, and I have my co-host Raymond Lowe from Intel. Hi, Raymond.
Good afternoon or morning. Where are you again?
or even evening, depending on where you are. So today we have two great guests that are going to share their insight and experience to help with your submission for the ADLINK 2020 Vision Hack, which is hosted on the Hacker Earth website, which is running at the bottom of the screen there. So we have Niels Kortstee from ADLINK. Hi, Niels.
Hey.
And we have Manas Pathak from Intel as well. How you doing, Manas?
Hey, good.
Hey. So why are we here? We're here as part of the ADLINK 2020 Vision Hack with a great prize of $10,000 and go-to-market collaboration with ADLINK and supported by Intel. And there's a number of other prizes winning through. Sadly, you've missed out on the Intel NeuralStick competition, which ran until the 31st of December, which we had some fantastic submissions for that. So thank you, everybody who submitted there. And Raymond and his colleagues have the nice task of just going through all of those before they send them out. What I'll do is just show you some information about the hack and the prizes that you could win. As you heard from Raymond, you have the opportunity of winning an Intel NeuralStick 2. Once you register on the 2020 Vision Hack page on Hacker Earth, you will receive an email with all the details on how to apply for your Intel NeuralStick 2. There are 100 to be won, so grab them while you can. Phase 1 winners will receive an ADLINK Visi AI Developer Kit, which is a bundle of powerful hardware and software to build your prototype with. The hardware is a Smart 2 board, which is industrial ready. It has a 4GB RAM, an Intel Atom 3940 CPU, and an Intel Myriad X VPU, so plenty of power for AI vision. The Visi AI also has very intuitive software included with it, the ADLINK Edge platform, which has vision tools, and OpenVINO and Node-RED included. As a Phase 2 team member, you will also receive direct support from Intel and ADLINK whilst you develop your prototype, so don't worry about support. The final prize. The winning team will win a cash prize of $10,000, but we don't stop there. An amazing opportunity to collaborate with ADLINK to validate the prototype with the market. That will include support and create marketing material like a press release, a promo video, a use case, a solution brief, and the support with organising meetings to validate your prototype with the market. This gives you a great foundation to really push forward in making an impact with your prototype. I think you agree this prize could be life-changing for you and your team, so good luck. Okay, so that's the hack in regards to the prizes, and submissions need to be in for Phase 1 for January 17th. We've got four themes. We have worker safety in industrial setting. We have manufacturing. We have energy, and we have distribution as well. Tonight we're going to be chatting with Niels and Manas about energy and worker safety and also production. So let's just have a little bit look at some of the themes that we're covering. Let's take a look at the computer vision themes for the 2020 Vision Hack. Manufacturers leverage powerful, real-time data from the IoT to increase uptime, perform preventative maintenance, enhance productivity, improve mobile accessibility, and a host of other benefits, like fault detection and enabling higher quality production and quality inspection. Distribution businesses have requirements for asset management, business process efficiencies, and new business models. Considerations like warehouse management, tracking and tracing assets in real time, security and transparency, monitoring asset movement within and around the facility to prevent theft or the misplacement of goods. Workplace safety. Thousands of workers die in industrial accidents each year in the world, and a huge amount suffer from non-fatal work-related injuries. Workers, employers, and insurance companies collectively face billions of dollars of direct and indirect costs due to industrial accidents, and individuals suffer unnecessarily. For example, think about personal protective equipment, PPE detection. Ensure people are wearing the correct equipment for hazardous environments. Fall detection. Enable identification and notification systems when workers experience injury or equipment is damaged. The energy sector is adopting the use of computer vision to enable smarter, automated, and more effective sensor data collection. Actionable data available when and where it needs to be. Example uses are wind energy producers identifying maintenance such as dirt accumulation on wind turbines, dead insects, and cracks in foundations or towers. In mines, automatic detection of anomalies in mines, for example leaks, fires, smoke, or even production blocks. So there we have it. They're the 4 themes that we have for the hack, that we're looking for people like yourselves to be able to help us solve those problems. And we'll support you in going to market and taking those solutions to market. And what we'll do by doing that is we will help you with the marketing collateral. We will work with you with meetings to validate the product. And once the product's been validated, we will help you with the go-to-market there as well and take things beyond that. So, Niels, hi, how are you doing this evening?
Hey, thanks, Paul. Yeah, I'm good.
Good. Niels, would you like to introduce yourself and just give some insight in your role at ADLINK?
Yeah, sure. So my name is Niels Kortstee. I'm product director at ADLINK, and I'm responsible for the product offering of ADLINK concerning the combined hardware and software to combine them into real solutions for customers. So something that really solves a business problem. It's not just a component, but the whole solution. So my main focus is on machine vision AI based solutions. So really combining the hardware from ADLINK with the components from Intel, the software from Intel, the software from ADLINK, all combined together to solve real world problems.
Awesome. So one of those is in production. Would you like to just give some insight on that one?
Yeah, sure. So I think you've got a little animation here. So this is just an example of one of the things that is in production right now. But we see this in manufacturing, but also in warehouse logistics all the time. Like products often need visual inspection before packaged and shipped. And often this is still a manual process. So it's very labor intensive. It is also very error prone because it's such a repetitive task and it's such a high volume. People make a lot of mistakes. So even though you think maybe people can do it a lot better than machines, it's actually not true. Machines, if you use machine vision, you can actually do these things a lot faster. So it makes it all faster, it makes it cheaper, it makes it more accurate. So the little video that you see was about detecting diseases and contamination in herbs. But you can also think about things like contact lens inspection. So these manufacturing of lenses, you need 100% of the lenses inspected before shipping them. And it's about 4,000 lenses a day that need to be manual inspected. And you need to see things like burrs, edges, particles, bubbles, scratches, etc. in there. Instead of doing that manually, we've got a solution where you would just put a camera on there with machine vision AI model running on there to detect any defects that have occurred during manufacturing. And the contact lens example, for instance, we've managed to increase throughput with 50 times. And we've also improved accuracy 95%. You wouldn't believe that 95%
wow.
over manual inspection. So those results are just tremendous, and they help businesses a lot be a lot cheaper, faster, more efficient, as you can imagine.
Yeah, and so on episode 1 of these industrial insights, speaking with Bridget Martin from Intel and Daniel Homeland and Daniel Collins from ADLINK. One of the things that really resonated with Raymond and I was the huge numbers in regards to return of investment with the quality and the safety and such like is seriously impressive when people are using vision as a sensor.
Yeah, exactly. What impressed me a lot, these numbers are so high, I couldn't really believe it first. And even if you present them to people that haven't seen it before, they're like, well, I don't really believe it. It can't be that good. But what we've seen is that there's actually a major benefit for a lot of processes in manufacturing.
Yeah.
Well, what I like is you run all this on the edge now. So instead of having a big server You have to upload all the data. It just happened in real time. So that makes me excited.
Yeah, that's really key with vision. What we've seen is you really need to run your model at the edge, so you can effectively process the video at a very high rate in real time, and then just as close to the source as possible. So the example you've seen, it can really be running on a smart camera. So really
Right.
at the camera itself.
Yeah, I saw that. That was a very interesting setup. You can mount your own C-mount lens. You can optimize for macro all the way down to maybe a wide angle lens or like a very macro lens to look at small details. So I love that. Give me a copy one day, guys. I want to try.
Yeah.
Especially, I think in the just a comment around this manufacturing, especially in the process manufacturing, the earlier you detect the defects, early in the cycle of the product, better chances are that you will be able to tackle it, before it hits end of the line. So usually your yields are better, and and you can basically remove that faulty parts before it hits and becomes a product.
Yeah, absolutely. Like in a lot of the processes, you have scrap, and reduction of scrap is one of the major goals of a lot of the people that run these factories, because that's a major pain for sure.
We should introduce Manas.
Yeah, Manas, please. Hey, thanks very much for joining us.
We ignore you a little bit there. We got you.
No.
He's our superstar from Intel, by the way, guys. Don't ignore him.
So Manas, thanks very much for joining us this evening. Apologies for that. I was going to move on to the introduction, as we were going to lead on to your side in regards to energy. Manas, please do introduce yourself and your role there at Intel. I think it's an absolutely fantastic role that you have there.
Hey, no worries, Paul. Thank you. So I'm Manas Pathak, a PhD in chemical engineering. Part of my PhD, I did machine learning for optimizing oil production. Currently, in my role at Intel, I'm global AI lead for oil and gas and energy. And basically, I work with partners and our customers in the energy sector to optimize AI solutions and bring the goodness of AI to deliver energy as clean as possible to the consumers. And then when you talk about energy generation, it could be wind, solar, oil and gas, traditional energy sources, and so it's really fantastic. The use cases that I hear from the customers and partners, and it's really exciting time to be in the energy sector at this time.
So one of the ones that that we discussed recently when we caught up was the toxic gases use case. Could you give us a little bit more insight into that and share that with everybody? By the way, viewers, if you have any questions for the team, please do just make a comment on whichever stream you're on, and we'll be able to respond to any comments. Sorry, Manas, please do.
Yeah, so I mean, this is basically a use case of flare stack monitoring. A lot of the times, whether it's a refinery, whether it's an oil and gas drilling platform, any asset that's have pressurized fluids in it, the asset manager needs to open some valves to depressurize the system. It's a safety issue if the pressures are above a certain level. So that's one of the ways you can mitigate these overpressured system by having flare the gases. And the combustion of gases needs to happen properly, because if you are flaring a toxic gas without properly combusting it, you're polluting atmosphere. And many of these assets have regulations from government and other bodies that suggest that how you need to flare your gases. So in real time, you have to monitor your flare stack that will tell you how the gases are being combusted in the flame. If the combustion is improper, that means you are basically exhausting some of the toxic gases that are not nice for atmosphere. And using vision as a sensor, you can have either a direct feed of video camera, or you can have sometimes you can have a thermal feed, like a thermal camera capturing the images of the flare, and then you can have some sort of segmentation model that can detect what are the zones of the flare. Is it improper? What is the flow looking like? Is it black? Are the hydrocarbons backflowing into the stack? Things like that can be monitored using computer vision. So this is really fantastic use case, aligns with energy and any asset that flares gases.
I never even know what that's flare for. This is the first time actually I know. For real. Like I thought they're just burning it off for fun. Definitely doesn't look no, so for serious work this is great. So
Yeah.
what does the scale that we're looking at? Like how many of those we have to like look at every day? So how do they manage this right now without the vision? So do they just manually doing it?
Right. So usually it's, manual, but with all the COVID-19 and the workers working remotely, there's more and more need of remote management and more real-time management, right? Not when your sensors are telling you that things are off in your plant. Before that, can you detect, how plant is functioning based on the flare stack? Because some of these things can be monitored and detected before you really see your sensors in the plant telling you that. So it's basically around the predictive maintenance and the predictive how can you predict any safety incident that might happen because of improper working of your facilities.
Yeah.
That's really cool.
Very cool. Very cool. So, I mean, that sort of leads on to sort of the next use case with Niels in regards to worker safety. So, especially in the energy space, the risk for worker safety, because to be honest, a lot of within energy is lots of high explosive stuff around. Niels, I believe you yourself and the team worked on a worker safety there in the energy sector, didn't you?
Yeah, that's right, Paul. So what you see here is what they call an iron roughneck. And so if you think about, the oil and natural gas production, you can imagine you need to kind of drill a hole. And this is the process where, people are involved. And one of the hardest, most dangerous jobs on the rig floor is the makeup and the breakout of a drill pipe and the drill collars. So the animation here shows this roughneck, this iron roughneck, and it's a piece of hydraulic machinery used to connect and disconnect the segments in the pipe of a modern drilling rig. So you can kind of imagine that if you drill and you have to drill deeper, you have these different parts of the pipe and they need to be constructed together, and when you pull it out, you need to disconnect them again. And there's a lot of accidents and injuries in that sector in general. So I think like numbers around like 1,500 accidents per year during drilling are happening. So you can see like injuries and fatalities even are something that you would want to prevent, right? You don't want people to get hurt when doing this. So we've worked on a solution here to using vision as a sensor again to help make this safer. And you saw a little video where actually the AI model was detecting when a worker was kind of breaching the zone of the drill when it was still in operation. So people get trained to operate and to look at everybody else that's out there as well, but also all the machinery that's out there, and these accidents are usually avoided when proper safety measures are in place. So with this machine vision AI solution, the first thing to do was let's trigger an alert so people can get retrained. So if they make a mistake, let's make sure they get a bit of retraining so we can prevent injuries. And the phase 2 of that solution was really to switch off the machinery automatically. So if people breach the zone, just switch it off so people can't get hurt.
Yeah, and that's one of the powerful things with edge computing is that instant reaction of being able to do that and switch off without any latency or bandwidth issues.
Yeah. Again, this is again key and it's key usually with all machine vision solutions. You can't really afford to send the real-time footage into the cloud over the internet because you don't have the bandwidth. And very often on sites like this, you don't even have any connectivity. So it's just not feasible. And then even if you could, if you send it, think about the amount of time you lose by sending the image and then getting a response back and shutting down the machine. It's just too late, right? So you can't do it that way. So you really have to do it at the edge, as we call it, so as close as possible to the source of the data.
Yeah, especially this. I don't trust the remote side. I don't. Like, I trust a lot of things, but when you have the extra wire, any extra wire is a extra problem to us.
Yeah, it's also a safety concern. It can break. It's a security concern.
Exactly.
Do you actually want the footage out there for people to potentially look at and hack?
Yeah.
Yeah, I've been to some of these drilling rigs and my training as a petroleum engineer, and we travel like 2.5 hours in the middle of desert in Utah to get to one of these rigs, and it's just like an island. They have everything to get things done, but a connectivity to the normal world is difficult in these remote
This
locations.
is super exciting. Can you tell us more about that? Like, so what happened? When was that? Like, is that like you went?
Yeah, so I was in my grad school, right, and we had this field trip to go to one of these drilling rig. There was an active drilling happening, so there was like a bus, and then all the students got to it, and then 2.5 hours of drive. I probably fell asleep a bunch of times, and then we reached there. And didn't know if Google Maps even work. I tried to get the map going, get the directions to my home. I don't think so. There was any mobile tower there, so it's basically out of nowhere in the middle of jungle sort of. But they have everything to get the job done. So there were all the trucks and all the pumping units and everything they had to get the job done. But if you want to send it to the cloud at that time, especially when a worker is entering a red zone, you better do it on site near the source of the data at the edge.
I'm pretty sure that I don't see oil next to my backyard, so I'm pretty sure it will be very remote.
Yeah.
So Manas, moving on with the energy side of things, there's sort of like the maintenance side as well, isn't there? And you've got a use case there in regards to the wind turbines for national energy.
Absolutely, yeah. So I mean, this is a very traditional use case. Don't even think about this as a wind turbine use case. Take a step back and think about this as any use case that involves maintenance of asset that is in remote location. So it could be a drilling rig, it could be a wind turbine, a solar farm, or any remote asset that needs monitoring. And if you monitor it well before any defect occurs, you are entering the realm of predictive maintenance rather than preventive maintenance or maintenance after the defect has occurred. So in this case, the small video that we saw is basically a drone flying over near a wind turbine, trying to see the defects in the wind turbine. Are the edges of the wind blades okay, or they are fading? Are there cracks in them? Is the vortex generator teeth are missing? Are they all good or not? Right. So monitoring your asset remotely and getting to know what is the condition of an asset is very important, right? I mean, we go to our PCPs every year to just get how my body is doing. Similarly, we gotta monitor how these assets are looking if we don't want to be in a condition where your asset is dead and there is a loss of production time. So that's the use case here, the monitoring of defects in wind turbine.
Yeah, that's
If
brilliant.
you summarize, so I have a question. If you summarize some of the top problems in energy sectors right now, can you highlight one or two things that you think is worth paying attention to these days? Let's say in the next 10 years, where do you think something should be really addressed? Yeah.
Right. So energy sector is going through a big pivot right now, right? The oil and gas and the traditional renewable energies are merging together. The industry is more looking like an integrated energy industry. So a lot of the traditional oil and gas players are coming into the renewable sites and thinking oil and gas as just another source of energy generation. So now from the perspective of technology, we need to see, okay, your solar, wind, your oil and gas, all are considered the sources of energy, right? And if you want to get the cleaner energy to consumers, you got to make sure that you produce this energy in the most carbon neutral fashion as well as most energy efficient fashion. So the use cases all revolve around basically carbon monitoring, making sure that you don't burn your toxic gases. Uh, uh, if you have these assets like solar and wind, you know, do a better job in maintaining these, do a predictive maintenance so that you don't have a trash of like silicon solar panels that, you know, yet we don't have a way to recycle them. And similarly, if you have wind turbines, we need to make sure that the wind turbines are properly monitored, because the grid operators who supply electricity to your and my home rely on these wind turbines to provide constant feed of energy. So if it's disruption in wind turbine energy production, that means you and I are going to see blackouts. So
That's right.
it's, you know, all of these are very critical, and, you know, it's use cases that needs technology to make sure that we are most efficient and most carbon neutral we can be while we produce energy.
Talking to you, I got hopes. I get blackout in the summer under 100 Fahrenheit. It's so hot and there's no power, no electricity for days. So I really understand that pain, and I'm so glad you're working on it. Thank you.
So Niels, it's, helping the community here for the hack. Where do you see some of the hot topic things in regards to things that they could be thinking about to make a submission on the Hacker Earth website? The link is there, stream along the bottom. What are some of the things that we're seeing businesses looking for help with that Vision as a Sensor could help solve?
Yeah, so generically, some of the things that I mentioned. So quality inspection, always in manufacturing, very hot topic. Worker safety is also something. I showed the example of on an oil rig, but this actually applies everywhere. In the warehouse, I was visiting a warehouse last year. I can say last year now, and the guy was showing me a picture of a forklift that was, well, it drove off the platform basically. He said, well, could you imagine if somebody got injured if that happened? Yeah. He also showed me a big dent in the roof of the forklift because something fell down. Like all these items are really, really important, and people are constantly thinking about it. And I think the other one is really about, okay, how can we make things more efficient, faster, cheaper? If you think about a warehouse, all these warehouses, they compete really on their price, right? So the only thing they worry about is worker productivity. The productivity, how fast can they do stuff? They need to understand how fast they can do it in order to understand what price they can offer, right? So anything they can do to make things faster, more efficient, and more accurate, go for it. I think last week I saw the live stream you guys did with both Daniels, and then Daniel was one of the Daniels was saying he was talking about the use case for the order validation and the packing of orders. This is an example of accuracy, right? So this one, it was really about, can we improve accuracy, and this helped them win more deals, right? So they're rolling out this solution to other sites now as well. They've been awarded the contract for North America entirely now to ship these Girl Scout cookies. So it's just an example of how improving accuracy is improving customer satisfaction and therefore helping them to win more business.
Yeah, exactly. Hey guys, we're pretty much out of time. Manas, Niels, Raymond, thanks very much for being with us. Please do have a look at the 2020 Vision .hackerearth.com website and check out our hack. Please do submit. Submissions close on January the 17th. This and the other live streams are available on the ADLINK Tech profiles, as well as the go250.ai ones. Guys, thanks very much, and good morning, good evening, and look forward to catching up with you on the next live streams. There is the Edge overview tomorrow, And then there is a number of live streams, which the inventory of those is on the Hacker Earth website as well. Thanks again, and good night.